So we kind of ran short on time today, so I'm going to go through and do some of the odd problems just to help you think through a little bit of your work. And I'll send this out. Hopefully you get a chance to take a look at some of these. Independent and dependent. Basically, independent, one event is not affected by the other. Dependent is that they are affected. So you're looking for the word replacement or non-replacement. So I'll just do a couple of these. Flipping a tail with a coin and rolling a 4 with a die. So flipping a tail 1/2, rolling a 4, 1/6. 1/2 times 1/6, 1/12. Nothing affected here. So they are independent. One was not affected by the other. Drawing a spade and drawing a heart from the same deck without replacing the first card. So this is going to be dependent because you take one card out, you figure that probability, now your denominator changes. I'll let you fill the rest of those, are not as complicated. 2 letters are chosen at random without replacement. So without replacement means each time you draw or pick, your denominator gets one smaller. So I'll do the vowels and consonants. There are 5 vowels. So the probability that both are vowels is 5 out of 26. And then the probability that they are still vowels in there is 4 out of 25 that are left. So the denominator decreases by 1 each time. Both consonants, I'll let you figure that out going the other direction. Marbles, 4, 3, and 6. A marble is drawn from the bag, replaced, and then drawn again. So every one of these, when you multiply these out, is multiplying something out of 13 times something out of 13. So both marbles are red. There's 6 out of 13 times 6 out of 13. It would have changed if this said not replaced, then each time this number decreases by 1. The other thing on this one, when it says neither is red, if you know the probability, sometimes the probabilities you found here can help you figure this out, but on this one, maybe not. Maybe it doesn't help you. Sometimes the last question is all the other choices. Okay, suppose you tossed a number cube 8 times and recorded results. The recorded data shows you tossed 2 5s. This was a little confusing at first. They're asking for the experimental probability. Remember, experimental probability gets closer to real probability the more trials that we do. So experimental probability of tossing a 5. So in this experiment, we rolled it 8 times, so it was 2 out of 8.25. The theoretical probability, what should happen, this is what did happen, this is what should happen. What should happen is 1 out of 6. Now, they're asking probability, they're not asking how many you should have gotten. If you want to compare these two, if you would have rolled 8 times, so I'm going to talk about this with a comparison. If we roll 8 times 1/6 is 1.3 repeating. This is what you should get. What you actually got was 2. So when you're talking about comparing the two probabilities, our probability in our experiment was higher than normal. That's because we only did 8 trials. Okay? Let's go to the back. So now we got some different tables giving us information. A tile is drawn out of a bag containing 4 tiles imprinted with D's, 3's, A's, B's, blah, blah. This is all I need to find. It is replaced and another tile is drawn. So basically they're drawing and recording, drawing and recording. So this table represents the experiment that they did. Okay? So I'm going to let you answer the question, what's the experimental probability of drawing D? The theoretical probability of drawing a D, there's 4 of those, 3 A's, 2 B's, and 1 C. So we have 10. 4 out of 10 is the theoretical probability. So this question is asking you to compare the experimental probability to the actual. Again, not very many trials. Okay, probability using tables. This may help you with some of your applications and some other things that we do along the way. So we have a table showing the people that play football and don't play football, broken down, boys, girls, totals, all that kind of stuff. So even though this one has this total of 110, be careful as we read through this. We might not be using 110 all the time. If we know something about the person in the situation. So what's the probability of randomly selecting an individual who is a boy and plays football? Okay, so this is probability of boy and playing football. So boys, 42, and play football is right here. This is all the boys. There's 75 boys. The boys, it says this is just a joint probability. So we're not doing given that. We don't know given that it's a boy. We just know boy and plays football, 42 out of 110. Again, you can change these to decimals. I'm not going to do that with my calculator. What's the probability of randomly selecting an individual that is a boy? Again, just kind of simple. How many boys out of the total? 75 out of 110. What's the probability of randomly selecting an individual that plays football? Again, fairly simple. Plays football, 54 out of 110. Those are just combined probabilities. You just got to find the right category on there. Okay, now if you randomly select a boy, what's the probability they play football? So the way that this is a conditional probability, and it says randomly select a boy. So they're saying you selected a boy. Given that you selected a boy, what's the probability they played football? So using our formula, that's the probability that they did football and they are a boy, divided by the probability that they are a boy. So in other words, we narrow it down to the boys. What's the probability that they did football and a boy out of the number of boys? And with a table, you'll be able to see a little bit more. So if you look up here, so the probability that they were football and a boy is 42. The probability that they are a boy, or the total that they are a boy, is 75. Now you might be saying, why didn't you do the 110s? Well, this is 42 out of 110. This is 75 out of 110. The 110s canceled. Some of you will figure it out this way. Some of you will go, well, I know my denominator now is 75 because I'm just looking at boys, so 42 out of 75. Either way, it doesn't matter to me. Just got to get to it. If you randomly select a football player, what's the probability they are a boy? That's the opposite order here. It does make a difference. Maybe. We'll see here. With the probability that we have a football player, probability we have a boy, given that they are a football player. So, probability that they are both, boy and football, divided by the probability of football. So what changed in this and? The only thing that changed is the denominator. So we still have our 42 that play football and are a boy, but this time our probability is divided by the football players, so 54. So 54 people play football, 42 out of them are boys. So some of you will read this and go to that chart. Some of you just want to follow it doesn't matter to me how you figure it out. Number 7, you roll 2 dice. The first die shows a 2 and the other die rolls under the table and you cannot see it. What's the probability that both die show a 2? So think about this. If they just ask the question, what's the probability of showing a 2 on the dice? Well, there's one combination out of 36. In other words, you got to get a 1 and then you got to get a 1 again. 1 out of 36. We did the whole dice rolling thing. But this is a different question. Given that, that's how I read that. Given that the first die is 2, given that the first die is a 2, so we got that situation, what's the probability that both of them show a 2? So normally the probability would be, there's only those cases where there's both 2, there's that one case. But what's the probability both of them show a 2? Well, you have, this one is already taken care of, so we know that one. There's no probability, it's 100%, it's 1. So times 1 out of 6. So there's a 1 in 6 chance that both dies show a 2. If you already know you have a 2, there's a 1 in 6 chance. If the question is, what's the probability that you get 2, 2, it'd be 1 out of 6 times 1 out of 6. So there's a difference there. Down here, losing our marbles. The fractions for these are on the other page. And one thing that we are assuming is that you're getting them in this order. And so when it says blue and red, it's really in that order, because if it gets more complicated if we change it to following blue, following red. But key to note here, the marbles are not replaced. They're replaced each trial, but when you do the blue and red, when you draw out a blue, then your denominator gets smaller. I'm not going to put the answer in there because we're going to check some of these. But the fractions are on the front. So I did most of those. Come with questions so we can talk. Take a look at your application problem, see what stuff you still need help with.